this is gonna happen a lot. I'm probably gonna drift away from answering the questions because playing guitar is so much fun. A couple of days ago, I asked you guys to ask me some physics and science and astronomy questions on my Instagram. And you asked some really great questions, so I thought I'd make this video where I answer those questions and play a little bit of guitar. Welcome to Guitar NA. How can you catch a falling star? That's a really nice question. So falling stars are basically meteors and meteorites that are, floating around in space. They come in contact with the Earth's atmosphere and they start plummeting through it. The Earth's atmosphere is full of gases, oxygen, nitrogen, a little bit of argon, a bunch of other things. But basically these gases don't move out of the way. They don't have enough time to move out of the way properly, so they compress and the pressure builds up and the temperature builds up and this piece of rock starts burning up. And it leaves behind this beautiful trail. We can see those things and they look like falling stars to us. And the vast majority of them burn up in our atmosphere. They never hit the ground, but some do, right? And the question of how can you catch that is actually really surprisingly deep. So there's this amazing project that's run out of Curtin University where I did my undergrad called the Desert Fireball Network, fireballs in the sky. And it's a bunch of geologists and geophysicists and planetary scientists who are trying to figure out how our solar system formed. And the way they're doing that is by catching meteorites and then doing quite a bit of analysis on them. So one of the things that they do is that they try to collect these meteorites and figure out where they're coming from by placing a lot of cameras all around the Australian outback that are facing up, right? And they're capturing the night sky. And when they see a trail from these meteorites, they can triangulate, they can locate its location, right? And so they were able to catch a bunch of meteorites really soon after they fell on Earth, which is an amazing achievement. I think that's really cool. So that's a really nice question. Do we seem heavier at the poles because we're not being affected by the centrifugal force? Yes. So weight is the amount of force that you're pressing onto basically the ground or the scales or something like that, and that's basically F, so that's the force in newtons, that's your weight, is equal to m, which is your mass, times a, and in this case a on Earth is 9.8 meters per second. So the mass doesn't change, but your weight will, in the same way that when you are going, at the bottom of a roller coaster, right? If you were standing on the scales then, at the kind of this part of the roller coaster, at the very bottom, the scales would read higher and you'll feel pressed down into your seat, right? Or when you're going the other way, up around, you'll feel slightly more weightless. So it's the same thing. And the Earth is spinning around, it's not spinning around at all next to the poles, basically. And around the equator, it's spinning at a relatively high rate. I don't know that rate. So you are slightly lighter at the equator than you are at the poles. And what's also really interesting is that the Earth actually bulges out a little bit around the equator. So it's not quite a sphere, it's an oblate spheroid. So it's something a little bit closer to a pumpkin. Okay, why do some popcorn kernels pop sooner than others? I don't know. I think there's a couple of things that we need to consider. Popcorn is basically a small explosive, right? It has something in the center that wants to expand really, and there's a shell around it that is stopping that expansion. And when the force from the inside becomes stronger than kind of the structural integrity of the outside of the shell, then it pops out. So I guess probably variation in the thickness of the kernel shell, or something about the amount of stuff that's inside, or slightly different expansion properties? I don't know. That's a really nice question. Can black holes appear out of nowhere without explosions or mergers? Okay, that's a really, really good question. We need to explain the difference between kind of the two main types of black holes. There's supermassive black holes and stellar mass black holes. And stellar mass black holes are, that's what it sounds like. They're black holes that weigh, about the same amount as stars do, right? So, if it's a one stellar mass, solar mass black hole, then the black hole has the same amount of mass as our sun. And then you have the supermassive ones. The supermassive black holes are black holes that weigh at least 1,000,000 times the mass of our sun. The black hole at the center of our galaxy is 4.3 million times the mass of our sun. And that recent imaged one, the one in M87, right, is 6.5 billion. 6.5 billion times the mass of our sun. So we have a pretty good idea about how stellar mass black holes form. It's basically from really, really massive stars that run out of fuel to burn. And they start burning heavier and heavier and less efficient fuels. And then they collapse onto themselves, and then they explode. And if they're big enough, they leave behind a black hole. Can they appear out of nowhere? Probably not, right? That's not really how physics works. We don't actually know that well about how the supermassive black holes form. There's a lot of really amazing research being done. We haven't solved that mystery just yet, which I think is also really exciting. But yeah, what's important to take away is that there's two types of black holes, ones that are relatively small in terms of their mass, and the other ones that are just gargantuan. Which is why, I guess, the black hole in Interstellar is called Gargantua. Alright, this is a good question. Do you think NASA will find life on Europa? Okay, so there is this moon of Jupiter called Europa, and Europa is beautiful. I love Europa because it is a world that is covered with ice, and underneath that ice there is a liquid ocean, and that's really kind of mind-blowing that there could be a liquid ocean that is on, the far edges of our solar system, so far away from our sun. So NASA is sending a mission to Europa. It's called Europa Clipper, and it's really, really cool. It's basically a chemistry lab that is going to fly next to Europa and try to catch some of the water and the ice that Europa occasionally, spews out into space, and analyze that water for signs of, organic molecules, maybe some kind of amino acids, something like that. I don't know. If I knew, I don't know what my priors are. I'm not sure what kind of bet I'd be willing to take. But I think there'd be something really interesting there, and if there wasn't, we wouldn't be going. Given government funding, you really need to make sure that, your missions really, really count. And it seems like Europa Clipper is going to do a bunch of really great science, so that's all that matters. Alright, next question. Who was the first woman in space? The first woman in space was this incredible Soviet lady called Valentina Tereshkova. And she went up into space in 1963 and did 48 orbits around the Earth, and was up in space for 3 days. So that's really cool. She's also the only woman that has been on a solo trip to space ever. My sister asks, what happened to your hair? I cut it. Guys, this video has been really fun to make for me because I got to talk about science and play guitar, which are like the two things I actually really want to do with my life. That's kind of all I want to do with my life. And yeah, this was really fun. If you liked it, I might make it into a series, so let me know if you liked it. If you have any questions or comments, you know, post them down below, or send me an email, or follow me on social media and send me a message there. You know, Instagram, Twitter, all of those things. I am Science Peter everywhere. Yeah, get in touch. You guys have been great. Thank you so much for watching. Big love.